Hello everyone, this is Professor Sunil Kumar Sharma from School of Computer Science, IMS Ghaziabad, University Courses Campus. Welcome to the second lecture on optimization techniques topic, job sequencing. Let us understand the next problem in job sequencing. The problem is a bookbinder company has one printing machine and one binding machine. Definitely, printing has to be done first and then binding. That is the logical sequence. There are manuscripts of a number of different books. Processing times for printing and binding are given in the following table. Determine the sequence in which books should be processed on the machines so that the total time required is minimized. Now, here are the books given in the table A, B, C, D, E. These are the books, and time in hours is given for printing. For book A, 5, 1, 9, 3, 10. Printing timings are given and binding timings are given like this 2, 6, 7, 8, 4. Now it is understood that printing will be done first and then binding will be done. So these books to be printed and binding to be done, A, B, C, D, E, these are the jobs. And the machines, there are two machines, printing machine and binding machine. So it is basically a two machine problem. Now since we have understood that the two machine problem order is printing and then binding, let us solve this problem. As we have understood that we are going to apply Johnson's algorithm, and the logic is that I have to identify minimum from the printing and binding. So I'll prepare one table here, one logical table here like this. So what is printing first and then printing and binding? Okay, binding. So in the order I have to find out in which order I have to do it. So the order is like, say 5 books are there, so I'll make 5 boxes here. So 1, 2, 3, 4 and 5. Okay, now find out the minimum from these timings. So 1 is minimum, so 1 is this, 1 is minimum. Okay, and this is for printing machine. So for book B, so job number B is to be done with minimum 1 unit of time on this side. So printing is to be done from this side, B. So this will be removed now. This book job is over. Now from the remaining one, what is the minimum? Minimum is 2. So this is for the book A. So A is to be done from this side, binding, because this is binding. So A will come here, job number 2, 2 units of time. Now this will be over. This will be removed from the list. Now what is the minimum from the remaining? 3 is the minimum from the remaining. So this is for the book D. But for printing will enter from this side. So D will enter from this side. D will enter from this side. And this will be removed from the list. Now, what is the minimum from the remaining? 4 is minimum from the remaining. This 4 is minimum. Now, this is for binding. So this will enter from this side. E will enter from this side. E will enter from this side. Now, this will be removed. Now, next is minimum is 7. So this is for C. Only 1 is left. So C will enter this. It means B job, book printing, B and binding, then D, then C, then E and A. This will be in this order, B, D, C, E, A. This is order. Now let us understand. This is the order I have listed here, B, D, C, E, A with a red pen, and I have identified the logic sequence is also illustrated. Minimum time in the given table is 1, which corresponds to the book B on printing machine. Therefore, allocation of the jobs will start at B first and then blank spaces. The book is B is eliminated as I have explained you, and then identify 2 as a minimum. So for book A on binding machine, so this will enter from the last side, from the last enter. So A has entered from the last. This way, continue this process till all the jobs are over. So this way, I have prepared this order job sequencing B, D, C, E and A. Similarly, okay. Now let us finding out total elapsed time for this. This question I have given here top. Now this way, this table is to be prepared for. Job is book here, basically book printing and binding. So this I have illustrated here. That's we have to write this job, and then printing, time in, time out. In time, out time we have to maintain. So machine name, and in time and out time, and machine name, binding, and then in time and out time. This is the structure of the problem. The order we will write here, B, D, C, E, A. Okay. So from the table, logically, for the first machine, in time will be always 0. In time will be always 0. Now, from the table, we'll see how much time it is taking on printing. This is taking 1 unit of time on printing. So I have entered 0 plus 1 is 1 here. Next job will start at 1. This will be remaining same for machine A. This will same. Now 1 for job D. Job D is taking here 3 units time. So 1 plus 3 becomes 4. This is here 4. Next job will start at 4. This will remain same. This value will same. 4. Now C book, how much time it is taking for printing? C is taking 9 hours for printing. So 4 plus 9, 13 is there. Next job will start at 13. Now 13, how much time E is taking? E is taking 10 hours for printing. So 13 plus 10, 23. This will be 23 here. Now 23 will come over here as it is. 23 will come over here. Now book A, how much time it is taking for printing? A is taking 5 hours for printing. 23 plus 5, 28. So printing machine will be free at 28. Starting at 0 and will become free at 28. In between, there is no lapse time, no idle time. But at the last, because all the jobs will be over by 30, we'll come to know. Let us calculate it this now. 30. So 28 to 30, 2 units will be idle time for printing machine. Now, first machine, book B, printing is over at 1. So its binding will start at 1. So in time for binding machine, machine B, different first machine, this will be same value. Whatever the out time for the first job, will become the in time for the next machine. Now, book B, binding time I have to calculate. Book B, binding time is 6 hours here. Book B, binding time is 6 hours. 1 plus 6 will become 7 here. I'll enter here 7. Why 7? Because it is greater than 4. It can be 4 or greater than 4. Then it will be entered as it is. If it is 3, then I cannot enter 3 here. I have to enter 4, whichever is larger. So this is the logic. So at 7, this will start, and D, how much binding time D is taking? D is taking 8 hours of binding time. So 7 plus 8, 15. 7 plus 8, 15. 15 will start here. 15 can come here because it is greater than 13 or same, greater than value. So 15 it will start. Now C, how much binding time it is taking? For C, 7 hours is the binding time taken. So 15 plus 7, 22 will come over here. 22 cannot be written here. Reason? It is 23. E will be over at 23. We cannot start at 22 for binding because 23 is the other. So 23 will come here. Now for E, how much binding time is there? For E, 4 units is the binding time given. So 23 plus 4, 27 will come over here. Next job we cannot start at 23 because the previous job A will be free at 28. So 28 is larger between 27 and 28. So 28 will come over here. Now 28, now machine A is taking 2 units of binding time. So 28 plus 2, 30. So total idle time, if I have to write to elapsed time, total elapsed time. So I can write total elapsed time. Total elapsed time is 30 hours. Idle time for machine A. Idle time for printing. At 30, all the jobs are over, but 28 printing machine was free. So 2 hours is the idle time. Now idle time for binding. What is the idle time for binding? At 30 it is over, but where it is, 1 unit is idle time here initially, and 1 unit is here initially, and then 22 to 23 idle time and 27 to 28 idle time. So 1 plus 1 plus 1. 3 hours is the idle time for binding machine. This is all in this numerical. So thank you.